Hey, g'day, it's Prezzo. Welcome back to the shop today. We're working on the Titan 60 model aircraft engine today. I think this is episode 7, and we're going to look at cutting the ports in the cylinder liner and the cylinder head, and if we get time we'll go on to the cylinder cooling fins. But I've got some new stickers, so let's get them up. One of the really cool things about getting all these stickers is looking at where they come from, and literally they come from all over the world. So we've got examples here from the USA, from New Zealand, from England, and parts of Europe. So yeah, that's fantastic. And not only is it interesting to see where they come from, but also it's interesting to look at the diversity. So let's have a closer look. So you got your miniatures, hey, 50mm. You got your really cool retro patina. You got a couple of multimedia ones. That's literally three-dimensional. And that is copper, believe it or not, with a glass enamel fused finish on it. Super cool. Don't know about this guy. He's supposed to be the second most handsome machinist on YouTube. I'm not so sure. I've seen better heads on broccoli. Well, this is the one we're doing today, and man, that's trippy. It's got to be the prettiest sticker out there. And it comes all the way from Ohio, from Kim Bazelic, and I love that he's put student machinist on the bottom of his sticker. And let's face it, we're all students, aren't we? If we're not learning something in the workshop every day, there's something going wrong. Let's get it up there. Now, Kimber also sent me this cute little cow. Not sure what that's all about. Could be a reference to Ohio. We'll put him up there next to Kimber. I've been struggling with this part of the project, trying to work out how to mill the ports in this cylinder liner, because that's a really critical part of the performance of the engine. If you get these ports in the wrong place, the engine is not going to run very well or at all. So I've just simply set this up on my surface plate, and I've used a digital height gauge to scribe off all of these marks. But when we go to mill this, I'll also use the DRO in the mill to double check. So the scribe lines are really just a sanity check for me as we go along. And to get the lines running parallel to the axis of the liner, I set it up on a V-block and set my heights on the end of the liner as well, just as an aid for setting this up when we go to the mill. Now, I met a gentleman online called Don Breimer. Now, Don is also building a Titan 60 engine, and he's nearly finished. And he's been sending me photographs of his parts, his engine, and it's been a real benefit for me to be able to compare what I'm doing with somebody else. So Don and I have been chatting backwards and forwards on email. Here are some photographs of what he's done so far, and it looks like he's doing an absolutely fantastic job, and it's an opportunity to compare notes with somebody else. Don's actually a lot further along than I am. He's almost finished, just going to fit the needle valve and the spray bar to his engine, and hopefully he'll get his running shortly. So thanks very much, Don. I appreciate the opportunity to talk to another builder. Anyway, let's get over to the mill and let's see if we can butcher this with let's see if we can finish this off with a 1/4" end mill. Right, this rather complicated looking setup is so that I can rest the cylinder liner on a pair of parallels. I've got another parallel and a spring pushing the pair of parallels up against a piece of 3mm wire. And that's so that I can rest this flange in the gap at the back where the moving jaw is. So it's going to sit like that, and then I've got a piece of copper which I'll put down here to protect that flange. And then I've got to align the edges of the transfer port slot so that the edges are sort of equidistant around the center there. Now, it's fiddly, and the reason I'm doing it this way is that I don't want to put direct pressure on the liner. The copper will take up any inaccuracy in the setup, and then I'll put an adjustable parallel underneath, and that will give me some support when I start milling the slots. To get these scribe marks so they're perpendicular to this jaw of the vise, I've just used a steel rule, and I've slid that in. I've got my magnifier on, and I can check to see that they're more or less vertical. Doesn't have to be perfect because we're going to use the DRO to set everything up, and we're going to do that now. Okay, well that's 0, 0, so it's exactly half the diameter of the sleeve, and we're right on the edge of that flange there. So all my dimensions are going to be taken from there. So I'm going to swap over to a 1/4 inch end mill and we'll start doing the slots. So I've offset from the end of the liner to the center of what will be the transfer port. Now this is a rectangular port that goes all the way across the liner, and if I lower that end mill down, you can see it sitting within those scribe lines there. So I'm happy that I've got that right. Now it's a distance from the end of the liner to the edge of the slot that's absolutely critical. The width of the slot is less important. Just the same, I want to get that right. So we're going to plunge the cutter down and make a hole, and then we'll just sort of nibble across left and right. Now according to my drawing, I've got to go 1/4 inch left and right, and that will give me the full length of the slot. Righto, here we go. Okay, I've stopped a few cars short there, but I'm pretty much on my scribe line, so we're going to do the same thing now, working our way across the right. Well, that's our transfer port done. Now we're going to flip this over and do the exhaust port on the other side. Okay, this setup's a little bit easier. So what I've got now is the parallels more or less in the middle of the vise. I've got the spring on this side to hold it all in place. And I've got a piece of end mill. This is a broken 1/4 inch end mill. And I can put that into the slot that I've already made. So when I turn this over, it'll rest on that end mill, and that will align the liner so I can do the opposite slot. So it's going to go sort of like this. I'll fumble fingers can get this right. A piece of copper can go against that jaw there. Just sort of got to make sure that everything's sort of bedded down and aligned properly. Alright, I've got this set up now with the end mill on the, what is my left hand side. Now in this exhaust port it's split into two parts. So there'd be a port on the left, port on the right. It'd be sort of like a divider in the center there. So these are both quite short, and these are higher up on the sleeve than the transfer port on the other side. So I'll do this one. The other one's the same, it's just a mirror image, so I won't show that. And then that's pretty much done. It's alright, just doing a visual check to make sure it's inside those scribe lines. Well, there's one. I'll do the other one off camera. There's both the exhaust ports done. I realised after I did the first one that I'd messed up on my measurements. I'd gone too far to the left by 1/16 of an inch, so I brought it back and that hit the scribe line. It's just really hard to see those scribe lines when it's in the mill. I can't get my head close enough and my eyes are shocking. But yeah, I recovered from that, so I think we're good. We'll go and try that now in the crankcase. Okay, I guess the question you all want to know is, does it actually fit? Well, if we push the liner in as far as it will go, you can see that the ports in the liner line up with the exhaust port in the crankcase. They're not perfectly though, because this opening in the crankcase is 5/16 of an inch, and the ports in the liner are 1/4 of an inch. So there'll be some mismatch there, but don't know for sure yet until we've made the cooling fins whether that's right or not. So the question is, how does this all work? And I must say, I thought I knew how two-stroke engines work, but until you actually make one, it's really hard to see it like visually. And here's a dummy piston that I've already made, and you'll notice it has a deflector or a baffle on the crown of the piston, and that faces toward the transfer port side. This is where the gas or air and fuel mixture will rush into the cylinder during that two-stroke cycle. So if we lower the piston down until it's just starting to uncover the transfer port and turn that around, you can see that the exhaust ports are now roughly 1/3 of the way open. So remember, the gas or the burnt gas inside the liner is now expanding and wanting to escape. It sees these open ports in the side of the liner and it rushes out through those ports as they get uncovered. But on the other side, remember, the transfer port is still closed. If we push the piston down just a fraction further, there's a gap there now, and the air-fuel mixture in the crankcase is compressed. So it wants to flow into the cylinder, and in doing so it rushes in, it hits the baffle on the piston, and then that directs that fuel-air mixture up to the top of the liner. Now as it rushes upwards, it displaces the exhaust gas that's already travelling out through these ports here. And at the bottom of the stroke, the exhaust port is fully open, and the transfer port is it's probably fully open as well. Not quite sure where that comes to at the bottom of the stroke. So now we've got the compressed charge of fuel and air at the top of the liner. Most of the exhaust gas is now being pushed out through these open ports, and as the piston ascends, it also scavenges some more of that burnt fuel mixture and gets rid of it. So that's the theory. Let's see how it works out in practice, but we're going to head off to the lathe now and do the cylinder head. Yep, do that next. That conical space there is the combustion chamber. The drawings aren't very clear about how you get the depth of that, but it also says that you can just machine it close, and then try the engine out. If it seems like it's got too much compression, you can just machine that deeper or machine the whole section, the spigot, shorter. But we're going to thread the glow plug hole now. It's a 1/4 by 32 UNEF thread. So this section of the head fits inside the liner like so, and what we need to do now is turn this around, machine the pocket for the glow plug, bring this to diameter and do some chamfering and so on. And to protect that surface that we've just machined, I've made up a little collet. So it's just a split collet that'll fit over that section there, and we'll grip on that in the 3-jaw chuck. Now, you probably saw me take this out of the chuck before, and you probably thought to yourself, you idiot Mark, why didn't you machine a bit of the outside of that diameter so you could set this up in a 4-jaw when you turn it round? Well, firstly, only my wife gets to call me an idiot, and secondly, I machined up a set of soft jaws in my smaller 3-jaw chuck. So this pocket in the front of the soft jaws is the correct size for this little collet, so that can go in, and we can tighten down on that. And that way we don't need to worry about dialing this in, or at least it's within the limits that we can work to on this little engine. So we're going to machine the outside diameter here, get the thickness of the head correct, and then machine the pocket for the glow plug. Oh, and I can machine up to this back edge here, and if I did happen to hit the jaws of the chuck, I won't smash anything. Good thinking, Mark. Well, that's the head machined to thickness and diameter. We're going to do the counter bore now for the glow plug. It's done now. Got a chamfer the back edge, but I'll do that off camera. And after that we're going to drill some holes and cut the cooling fins, but just for now the notes say to finish up at this point, and we'll do all of that as ancillary operations later when we got the cooling fins done. Alright, let's stock for the cooling fins. Made that a bit too tight. What I have to do here is machine the bore of the cooling fins to fit the small end of this sleeve. Now, when I made this sleeve there were two different diameters on this outside cylindrical part, and this top section where the cooling fins will go is about 1/2 thou bigger than the smaller section that fits inside the crankcase. So if I can machine that bore so that the sleeve will go on up to the shoulder, which is just above the port, then I can do the rest by shrinking it. So it'll be heated up in the oven, we'll drop it onto the liner, hopefully, and then when it cools it'll be permanently fitted to that. So I'm going to measure this small end of the sleeve now with my calipers, and we'll dial it in and we'll machine that bore out. Just did a spring pass there, and that's 1.93 undersize, but that part's quite hot, so I'm going to let that cool down and then we'll do 2 more passes and hopefully we'll get it right. Getting quite close now. The problem with this is you've got to know how much deflection you get in your boring bar. So 0.44, my DRO says 0.49. And I just did a spring pass. 0.42. And that's it. So because this is a bigger diameter up here, it won't go any further. It's almost at the shoulder there now. So when we put this piece of aluminium in the oven and heat it up, it'll expand enough that the liner will drop in. Just went back and reviewed the notes, and it talked about a 1 thou interference fit, and it's more like about 2. So I took another thou out of that bore, and now that slides in until it hits that shoulder, and it won't go any further until we heat this up in the oven. This is what I come up with to hold this part while we machine the outside and do the fins. So this mandrel will stay in the chuck now, and that's a really close fit, like so, and this little cap will go on the other end, and we'll put the tailstock in there to support that. Now we can machine the outside and cut all the grooves for the fins. Now just to make sure that nothing moves, I'm going to put a tiny spot of Loctite there. I can heat that up to get it off later, but I want to be absolutely sure this doesn't want to try to spin, or if the tool catches, yeah, we don't want a disaster. So Loctite it is. That's probably enough. Alright, let's let that cure. Alright, that's the finished outside diameter, and what we need to do now is set up some special tools and plunge cut from the outside to create each fin. What fun! This afternoon, just before I packed up, I machined what will be the edge of the lowest fin on the cooling fin stack. So it's just a straightforward turning operation, so I didn't bother to show that on camera. And what I've done this morning is I've just blued up the outside of that stock there, and I've worked out where all of the grooves will go. So there'll be 4 grooves, 5 fins, and all the fins have to finish at exactly the same thickness. Now what's made it complicated is that I'm using a 3/32 parting blade, and on the drawings it specifies the distance between the fins is 100 thou. Now 3/32 is about 93 thou, so there's a bit of a discrepancy there, but I figure it's not going to be a big deal. But what I had to do was go back up to my computer and work out in CAD what the correct spacing will be. So on my drawing I've got the offsets from the surface that I've just machined. So it's 4.33. If I do that 4 times, that will give me the 5 fins that I need. So I'm going to do that with the DRO, and I'm going to go ahead now. I'm just going to show you part of this process, because I've really got to concentrate, and I'm using lots of coolant, I'm using medium speed, and I'm using an inverted parting tool, which means I've got to run the spindle of the lathe in reverse. And it's just a case of watching the DRO really carefully, and just trying to avoid a catch which will totally destroy this whole thing. But I'll meet you when we've done all of the grooves, and we're just going to do some clean up and chamfering to finish up. Well, there's the end result. That went better than I expected, but that sleeve now is in there permanently and it's not going to come out without a fight. And we should be able to drop that into the crankcase now. And the bottom of the cooling fins seats on the top of the crankcase, and that will later on be held down with 3 bolts. And the cylinder head, although it's not finished, it sits on the top of the liner. And as you can see, all the gaps between the fins look even and accurate, which is what we're after. So I'm pretty sure that's a wrap. Let's finish up. Well, with that assembled now, you get a sense of how big and chunky this engine's turning out to be. Adding those 2 parts today has, certainly increased the height of the engine and the mass as well. In the next episode, we're going to make the prop driver and the spinner that holds the propeller onto the crankshaft. Now, I want to be able to do that because I want to be able to crank this over when I start making the connecting rod and the piston, just to check for clearances and fits and so on. So we'll do that. We're going to do some more work on the cylinder head, cut the cooling fins. We're going to drill the radial holes through that and the cooling fins underneath and into the crankcase so we can bolt all that together. So yeah, that's where we're headed for the next one. Join me for that. And thanks for watching today, and I'll catch you on the next episode. See ya.